Dear students, today we are going to discuss about the advanced learning concepts in machine learning course. The course code is 191IT7310. The outline of this PPT is machine learning and its types and what is reinforcement learning, representation learning, feature learning, neural network, deep learning, active learning, ensemble learning, bagging, bootstrap aggregation, boosting, gradient boosting machines. We will see one by one. Machine learning. What is meant by machine learning means a computer program is set to learn from experience E with respect to some class of task T and performance measure P. Performance measured by P. If its performance at task T as measured by P improves with the experience, we will call it as the machine is learning. This is the definition for machine learning. The task T performance P with the experience E. Performance performance at the task T, performance of the task TP improves with the experience. We call it as machine is learning. Machine learning is a subfield of artificial intelligence and involves the development of algorithm and statistical models that enable the computer to improve their performance in tasks through experience. These algorithms and models are designed to learn from data and make predictions or decisions without explicit any instructions. Examples of machine learning are a robot driving learning problem. Here, the task T is driving on highways using vision sensor. The performance is average distance traveled before an error. Training experience is a sequence of images and steering commands recorded while observing a human driver. We are giving the experience by means of the experience. The task T performance P is average distance traveled by before an error is improving. And another example is handwriting recognition learning problem. In this, task T is recognizing and classifying the handwritten words within an image. Performance P is percentage of words classified as correctly. And training experience is a data set of handwritten words with given classifications. More number of data sets will give accurate results. The performance of the task is improved when we are giving more number of training experience data sets, it will improve the performance of the task. This is a type of machine learning: supervised learning, unsupervised reinforcements. These are some types of machine learning. In supervised learning, machines are trained using well-labeled training data. Well-labeled labeling is very important in supervised learning. They predict the output based on input and output pairs to learn the mapping functions. It will predict the relation between the input and output pair, and it will predict the output by means of the previous labeled data. Okay, this is called as supervised learning. In unsupervised learning, machines are trained using unlabeled training data. They discover the hidden pattern and insight from the given data. Reinforcement learning. An agent makes sequence of decisions or action in an environment. It learns through interaction with the environment, receiving the feedback. We will detailedly discuss about the reinforcement learning. It is a science of decision making. It's all about the learning the optimal behavior in an environment to obtain the maximum reward. In reinforcement learning, environment is giving the feedback. From the environment we should get the maximum reward. In reinforcement learning, the data is accumulated from machine learning system that use a trial and error method. It tries, if you get the negative reward means, in negative feedback means it will change. If the error occurred means it will change the decision, like that. Data is not part of the input that we would find in supervised or unsupervised machine learning, and an autonomous self-teaching system that essentially learns by trial and error. It performs the action with the aim of maximizing reward. In reinforcement learning, our aim is maximizing the reward. See here, this input raw data is available in this, different shapes are available, either rectangle and triangle and circular shapes are available. These are the data sets we are giving to the machine model. This is the environment, and the agents is also available. Selection, some of the algorithm is selected in the model. It gives the reward, so it will take the best action. It will give the good output. It classifies based on the reward. It classifies this raw data into some one group. Similar data are grouped as one group, like that. All orange color circles are grouped, and blue color triangle are grouped, and that uda color, like that, are grouped in one classification, like that. This raw data is grouped into three separate classes. What are the types of reinforcement learning? Positive reinforcement learning and negative reinforcement learning. Positive and negative reinforcement. Positive means it is a process of adding or presenting a desirable stimulus following a behavior which increases the likelihood of the behavior being repeated in future. That means what are the decision can be taken. If we take one decision, if it will lead to good, or otherwise if it lead to a attaining our goal means, we can repeat that step. So it will be taking it will be taken as positive reinforcements. What is the advantage of this type? Effective in behavior modification and fosters the positive relationship and maximizes the performance and sustain the change for a long period of time. What is the disadvantage of this type of reinforcement? Potential for over rewarding and dependency on external reward diminishes the result. These are the disadvantage of this type of reinforcement. And what is negative reinforcement? Negative reinforcement is defined as removal or avoidance of an unpleasant stimulus to increase the desired behavior. If we want a behavior, for that, in order to reach that goal or behavior, what we expect from the what are the things we do not do, like that it will give. The negative reinforcement is defined as the removal or avoidance of an unpleasant stimulus to increase the desired behavior. What is the advantage of this type of reinforcement? Effective in avoidance learning and encourages the problem solving method, increases the behavior. What is the disadvantage of this type of reinforcement learning? Potential for misinterpretation and dependency on negative conditions. These are the two disadvantages of this type of reinforcement. And what are the elements of reinforcement learning? Policy, reward function, value functions, and model of the environment. These are the elements, 4 elements of reinforcement learning: policy, reward function, value function, model. Okay. Policy defines the learning agent behavior for given time period. We should give the policy in what are the situation it will work, and uh, like that. Okay, it is a mapping from perceived state of the environment to action to be taken when in those states. This is the policy. And then reward function, a function that provides a numerical score based on the state of the environment. It will give +5 +10 like that. Okay. To define a goal in a reinforcement learning problem, we are using the reward function. Values function specify what is good in the long run. The value of a state is the total amount of reward an agent can expect to accumulate over the future starting from the state. Sometimes the in current situation one decision may be taken as good, in long run it may lead to negative. So the value function only defines what are the decision if we take, then it will lead to good reward, like that. And then last one is the model of the environment. Models are used for planning our model or algorithm, like that. And what are the applications of reinforcement learning? In robotic, chess playing, adaptive controller, we are using these reinforcement learning. Robotics with pre-programmed behavior are useful in structured environment such as the assembly line of the automobile manufacturing plant, where the task is repetitive in nature. You can take any robotic automation. If any manufacturing company, pick and place machines are available in assembly line, the work are repeated. If we want to manufacture 1000 number of car, means we are making manufacturing one by one, seats or screw or tire or glass fitting, like that. Any work are combined cumulatively doing the work process is repeated. At the time we are using the robotic, and that robots are pre-programmed. We already inserted the program, taking and placing in some points, that is programmed. What is x and y, where we have to put the screw, like that we already programmed. In that situations we are using the reinforcement learning. And chess playing also, a master chess player makes a move. What is the next move? What will be the best move? When we are moving this or that, whether it will lead to good victory or not, like that. So for that we are giving so much of training data. The choice is informed both by planning, anticipating possible replies and counter replies. Adaptive controller, this is also one of the applications. It adjusts the parameter of your petroleum refinery operations in real time, such as temperature, pressure or flow rate, to optimize the production efficiency and quality. In industries these controllers are very much used. Sometimes maybe pressures or temperatures or flow rates are varying. At the time, based on the situations we can use. So for that time we are using the reinforcement learning. And what are the applications? Robotics, chess playing, and adaptive controller. And representation learning refers to a set of machine learning technique and algorithm which aim at automatically discovering and deconstructing a meaningful representations or feature from raw data. Machine learning itself, what is machine learning? We are inputting the raw data and we are extracting the feature. Okay. Yi equal to function of xi. Okay, xi is the input object, yi is the representations. Representation learning is classified into supervised, self-supervised, unsupervised. Unsupervised talks formulation for this VAE, GAN in painting, super solutions are examples for that. And self-supervised define meaningful pretext task, predict the rotation of an image, that is predicting the hand recognition, generating pseudo labels for pretext task, train the model to solve the pretext task. These are the steps. And supervise means trained model on classification task, reuse representations learned by intermediate layer, require large labeled data sets. Supervised learning means require the large labeled data sets. That is main. And then semantic feature and downstream task classifications, search, recommendation. These are the works are done. We may have a lot of data that contain, that may be text, or that may be image, or that may be logs. From that one representations will come, that from that representation we may either use supervised or unsupervised, self-supervised learning. From that we are extracting some features, and finally we come to the come to the conclusion, classification, or we may perform some search work, or some we may recommend, like that. Okay, these are the benefits of representation learning. Feature learning, feature selection method, filter method, or wrapping method we can use, or embedded method we can use in order to get the feature. Okay, we should learn the feature from the raw data. Feature selection and classification, feature selection and classification, wrapper method and then embedded method, embedded feature selection classifier, both are embedded in one thing. That's that is the that's why it's called as embedded method. Or what is the difference between the feature learning and representation learning means? This is the process of selecting a subset of feature that are most relevant and informative for the target variable. This is the process of learning a new representation of input data that captures the underlying structure and pattern of the data. Efficient wise, if we compare, feature learning is simpler and representation learning is more complex and slower. Information may discard some useful information in the future, but representation learning may discover new and hidden features. Okay, then we will move to the neural network topic. Neural networks are artificial systems that were inspired by biological neural networks. A mathematical model or a computing system made up of number of simple and highly interconnected processing elements. This neural network is a mathematical model or a computing system made up of number of simple and highly interconnecting processing element. This looks like neural, so it's called as neural network. This helps in processing the information by dynamic state response to the external input. They are a network of hidden layer, input layer, and output layer. Neural network contain three main important layer. What is that? Hidden layer, input layer, and output layer. Okay. Non-interruptible and computational models for threshold logic. and non-interruptible models are those which can't be interpreted or understood even if we observe the hidden patterns. See this neural network. This is contain three important layers are there. This is a forward propagations. In this input layer is there. Hidden layer is mentioned as yellow color, and output layer. Three layer are important. From input to output, this is called as forward propagation. From output to input, this is called as error backward propagation. Okay, this is called as neural network. And what is the component of neural network? Neuron or node, and weight or bias, input layer, hidden layer, and output layer. What is the activation function, loss function, optimizer, back propagations? These are the component of neural network. Node means yellow color and blue color round is there, no? That's called as neuron or node, building block of neural network, basic unit that receive the input, apply weight and perform the computation using the activation function and pass the output to the next layer. Weight and biases means parameter associated with the connection between the neuron. Some may have more weight, some may have less weight. Based on the bias or weight, we will perform the calculations. Okay. Weight determine the strength of connections, while biases allow the model to fit the data better. And input layer, the initial layer that receives the input data. Each neuron in this layer represents the future or input variable. What is meant by hidden layer? Intermediate layer between the input and output layer, where complex transformations and future extractions are occur. Multiple hidden layer allow neural network to learn hierarchical representations. Okay, one neural network must contain one input layer and output layer. More number of hidden layers are there. Output layer, the final layer that produces the network's output. The number of neurons in this layer depends on the types of task. Maybe either it may be classification or regression task. Activation function, it is a non-linear function applied to neuron output, introduces a non-linearity and enabling neural network to learn complex pattern. Sigmoid activation, these are the example of activation, tan h, like that. Loss function, loss functions measures the difference between the predicted and actual output. Cross validation loss, these maybe there we already discussed about some activation functions, some loss functions. These are, it guides the network during the training by adjusting the weight to minimize the difference. Our aim is to minimize the difference between the predicted and actual. What is if we have difference between the predicted and actual, we may get loss. Okay. Optimize algorithm that adjusts the weight and biases based on the loss function's output, aims to minimize the loss and improves the model performance. For that only we are using the optimizer. Back propagation, the process of updating the weight and biases by propagating error backward through input layer. Okay. What are the types of neural networks? Convolution neural network, recursive neural network, recurrent neural network, and shallow neural network, multi-layer perceptron, long short-term memory, sequence to sequence. Okay, these are the neural networks that's already available. And we move to the next topic, deep learning, a branch of machine learning which is based on artificial neural network or deep neural network. These neural networks are inspired by the structure and function of the human brain's biological neurons, and they are designed to learn from large amount of data. What is the difference between the machine learning and deep learning? Means we are having so much of data and images. The images are inputted to the deep learning model. We are getting more, we are extracting the future from that, and we are classifying either classification task or clustering task we are doing. Okay, capable of learning complex pattern and relationship within the data. Deep learning algorithm can automatically learn and improve the data without the need of manual feature engineering. Training DIN typically require a large amount of data and computational resources. GPUs are we are using. The GPU means graphics processing unit. You can do the deep learning in Colab itself. Colab, we select GPU for processing, not CPU. CPU is low computation power. GPU, graphics processing unit, okay, to train our DN. Here see, input layer and output layer, more number of hidden layers are there, okay. It's also, this is example for fully connected artificial neural network, okay. The difference between the neural network and deep learnings are the structure and architecture wise, definition wise, time and accuracy wise, the difference are given, okay. And what are the applications? In what are the situation we are using? Computer vision. In computer vision, object detection, recognition, image classification, image segmentation, and second application is natural language processing. In natural language processing, automatic text generation and language translation, sentiment analysis, speech recognition. For all, we are using the deep learning model, okay. This NLP application is ChatGPT. In the ChatGPT, we are it will generate the text, okay. It automatically generate the text based on the previous predicted raw data, okay. Sentiment analysis means based on so much of YouTube comments are there. It will capture all the raw data and it will give the content of it will show the behavior or character of the content, good or either good or no, like that, okay. This is used in applications such as customer service, social media monitoring, political analysis. For all, we are using the sentiment analysis only. In reinforcement learning, game playing, robotics, control systems are using. Thank you students. Thank you for your patience.